What's up YouTube, it's me again, and this time as I promised with a video on React Tree Fiber. Look at this fantastic scene that we have today. There's a bunch of interesting elements on it. For example, there's this car that continuously moves in this three-dimensional space and the same axis where there are a bunch of boxes floating around. Then there is a ground that reflects all the elements of the scene, and the car does it too. There's complicated post-processing effects such as a bloom. You can see it here, like close to the rings of the scene. Then there's a little bit of RGB shift, and all of these effects by themselves would be pretty difficult to achieve in Three.js. But React Tree Fiber makes it effortlessly to build this kind of scenes. In fact, I did this one in like 300 lines of code or so. I'm going to assume in this video that you know at least a little bit of React and Three.js, so it's not necessarily an introductory video, but apart from that, it's going to be somewhat easy to recreate this kind of scene. So yeah, without further ado, let's get this introduction in this fantastic library, and hopefully we can learn something new together. So yeah, let's go. I'm going to use create React app to initialize the project, and these are the only two commands that you need to run to download all the dependencies that we're going to use in this project. I'm going to run these two commands on my VS Code terminal one after the other, and I'll wait until each of them is finished, and right after that we can start coding something. After the project is initialized, we have to modify it a little bit, index.js, to use the new create root function for React. And we also need to make a simple CSS file. Just copy what you see in the screen and we'll be good to go. And now we can start hacking app.js. Just replace the initial file with this one. Canvas is the most important element in React Tree Fiber. It abstracts away the renderer, a default scene, a default camera. In this case, I'm also specifying shadows because I want the canvas to also enable shadows. And suspense is going to be used because there's plenty of hooks in React Tree Fiber that will, for example, download a texture or download a model, and they will need this suspense block to work correctly. All the React Tree Fiber hooks need to be called from within the canvas element, so that's why we're creating a car show component, which for now is just null. And I've just added some elements inside the car show component. And the beautiful part about React Tree Fiber is that you can use this JSX syntax to specify the elements of your scene. This is very convenient because especially when you have bigger scenes, you want to componentize all these elements. And using this syntax is a way of keeping all of your elements very well organized. And you'll see how useful this syntax is as soon as we start having more and more components in our scene. But for now, as a quick reminder, orbit controls is a component that basically helps, is a Three.js helper. It makes it possible to move the camera around the fixed point, which is the target of the orbit controls. And in this case, the target is basically the center of the scene, but just slightly above it because this represents the y-axis. Perspective camera is the camera that we're going to use for this project, and that's the position of the camera. Field of view, we're making sure that this is the default camera that React Tree Fiber is going to use. And also when you're trying to import this component, make sure that it comes from Dre and not the Three.js library. And now we're ready to test the scene. Let's open up the terminal in VS Code and just run npm run start. And if you can see a red cube that we can spin around, then yeah, you did it. It's working. Now, I'll soon get into the details of how you're supposed to create a mesh and materials, but for now I want you to replace this block with this one. The first thing that we're trying to do is to change the background of our scene, and this is how you would do it. So basically, it's like if we are creating a new color in Three.js, but the arguments that we are passing to the color constructor are passed with the args property, which takes an array, and the elements of the array are basically the arguments that the constructor of the object of the Three.js object that we're trying to create would normally take. So in this case, the color constructor would take 3 elements. We want a dark background, so all black, and we're passing 0 everywhere. The attach property instead is just a way of attaching a constructed Three.js object to the property of another object. So in this case, since we are inside the canvas component, attach is going to attach this color object to the scene's background, and that's why we're specifying background here. We scroll down a little bit, we also created 2 new spotlights, and the JSX syntax that you see here is equivalent to what you're seeing above. So in this case, it's like if we are creating a new spotlight in Three.js, and every property that we specify afterwards, it's almost if we were specifying it right after the object was created in Three.js. So for example, intensity 1.5 in this case is equivalent to creating the spotlight and then specifying the intensity property. React Tree Fiber also has a shorthand for all the properties that have a set method like color and position. For those objects, and these are usually vector-free type of objects, you can specify an array with 3 elements, and that makes it incredibly easy to just specify the color and the position, for example, of the spotlights. Our next step will be to create the ground of the scene, and I'm going to do that with a new component. And now we can spend some time to define how you're supposed to create meshes in React Tree Fiber. You usually have a mesh component which takes 2 children, a geometry and a material. So the geometry in this case, remember when we are passing the args property, it's basically like saying with which arguments do we want to instantiate this geometry. If we were to look at the plain geometry docs in Three.js, you would see that it takes 2 parameters, actually 4, but the most important parameters are 2, like the width and the length of the plane. And in this case, we're basically constructing the plane geometry with 30 for both the width and the length of the plane. We also want to make sure that the mesh can cast and receive some shadows. And if you remember from my previous videos on Three.js, when we want to rotate a mesh along the x-axis, you would usually do it this way by calling the rotation property of the mesh and then .x. So in React Tree Fiber, every time that you want to access a property that is like a sub-element of another property, so in this case it's rotation.x, you would do it with a dash. So this property is effectively equivalent to calling mesh.rotation.x equals the value that we're assigning for the rotation. So in this case, minus 90 degrees. And I've also added some properties to the mesh reflector material, which is a new material from the Dre library that makes it possible to reflect all the objects of the scene on this plane. Now, I'm not going to explain all of the properties of the material because for the most part I don't understand them myself, but this is the preset that we're going to use for this project, so feel free to copy and paste the properties that you see here on screen. Before we can start using this ground component though, we'll need 2 textures. You can either get these 2 textures from the repo of the project, and I'll copy and paste this link on the description of the video, and you'll basically need terrain-normal.jpg and terrain-roughness, or you could use HDRI Haven, and by going on this link you need to download the roughness texture and the normal texture. From now on, I'm going to assume that you made a new textures folder under public and that you have the 2 JPEGs in there. Getting textures with React Tree Fiber is super easy. You just need to use the useLoader hook, specify which kind of loader you want to use. In this case is the texture loader object from Three.js, and then an array of textures that you want to download. So in this case, we just want the roughness and the normal map. And as soon as both are ready, we want to apply some properties to both textures. We want to set the wrap mode to repeat and the repeat scale to 5. Also, when we're dealing with PBR textures, such as roughness and normal maps, normally you want both of them to have the linear encoding tag specified. In this case, just because it looks better this way, I'm applying the encoding only to the normal texture, but normally you will want to apply to both. I'm just making an exception to this rule with this project because it looks better this way, and that's the only reason why I'm doing it. And now that the textures are ready, we can use them inside the mesh reflector material by specifying these 3 new properties. And then we're ready to go. We can basically use the ground components inside our app. And with just a few lines of code, we now have a ground component in our scene that is reflecting the 2 spotlights, and it's also specifying the textures that we just downloaded. Also, the background of the scene changed and now it's all black. And this is basically going to be the base for the rest of the project. I'll stop this part here. You'll be able to find the full source code of the project in this repo. I'll publish the link in the description of the video. And in the next one, hopefully we'll be able to add the rings that were surrounding the car in the original scene, plus the car itself. And until then, I hope to see you in the next video.